We have learned about ionic, covalent compounds, acids, and bases. So now we're going to talk about what happens when these substances combine. So first thing we need to know is how to write a chemical equation. And when you have a reaction, you're going to have one or more substances, those are going to be your reactants, change into two or more new substances, and these will be your products. We're going to separate our reactants from our products with a yield sign, so it's going to be an arrow, usually pointing to the right, but as we've seen, sometimes you can have a reversible reaction where your arrows go both directions. You're going to separate substances from each other with a plus sign, so if you have more than one reactant, you're going to have a plus sign in between each compound. If you have more than one product, you're going to have a plus sign in between each compound. Your reactants will always be on the left, even if it's a reversible reaction, and your products will always be on the right. So reactants to products. So if we look at the chemical equation for rusting, we get iron plus oxygen gas yields iron 3 oxide. So if you notice, this equation is not balanced. If we count our atoms, think of this arrow here as an equal sign. So if this arrow is an equal sign, we need to have the same number of atoms of each element on each side of this equal sign. And here we have one iron, and on this side we have 2. And then here we have 2 oxygen, and on this side we have 3. So this equation is not balanced. It is simply a skeleton equation. We need to balance our equations. Now in nature, this happens on its own. There's not some little fairy there sitting there and counting out the atoms. It's naturally going to balance itself. But when we do the math, we need to write it out on paper, and then we need to go back and balance the equation. So we need to fix how many of each thing we're going to actually have if we were to do this reaction. We have to follow the law of conservation of mass. So matter is neither created nor destroyed. And so whatever your weight is on your reactant side should be the same on your product side. So every balanced equation is going to have the same number of atoms of each element on both sides. That's going to keep the mass equal on both sides of that arrow, the yield sign. So rules for balancing. You first need to make sure your formula is correct for all of your reactants and products. This is where you could also state your state of matter: solid, liquid, gas, aqueous. You're going to put the reactants on the left, put the products on the right, separated by the appropriate symbol. This will be your skeleton equation. Most of the worksheets that we'll get will be done up to this point for us. There are some where you're going to have to figure out the products, but you'll always be given a reactant. So you're going to count the number of atoms of each element on your reactant and your product side. And then you're going to balance the elements one at a time using coefficients. You cannot change the subscripts. Okay, remember those subscripts are what make that compound that compound. So you cannot go changing subscripts to balance. You cannot put a coefficient, which is a big number, in between a compound. You can only put it in front of the compound. You need to check that both sides have an equal count of atoms. And then put all of your coefficients in the lowest possible ratio if necessary. So basically reduce. Look at each of your coefficients, and if you can, reduce. Okay, so let's look at a couple of examples. First one is hydrogen gas and oxygen gas making water. So we're going to list the elements that we have. We have hydrogen, we have oxygen. And on our reactant side, we have 2 hydrogen, 2 oxygen. On our product side, we have 2 hydrogen and 1 oxygen. Remember, we're counting individual elements now, not the compound. So now we need to put numbers in front of the compounds to fix our count. And when you put a coefficient there, you're going to multiply by the subscript. So right now the only thing off is our oxygen. So we have 2 over here and 1 on our product side. So if we put a 2 for our coefficient, this 2 is going to multiply by both of these subscripts. So now this makes 4 hydrogen over here and 2 oxygen. So our oxygen is equal on both sides now, but our hydrogen count got off. So if we have 4 on our product side and 2 on our reactant side, we need something to multiply by 2 to get 4, and that's going to be 2. So 2 times 2 is 4. So now our reaction is balanced. We have 2 times 2 is 4 hydrogen, 2 times 2 is 4 hydrogen, 2 oxygen, 2 times 1 is 2 oxygen. So that one is balanced. Let's try another one. Ammonia can break down into nitrogen gas and hydrogen gas. So we have nitrogen and hydrogen present in our reaction. On our reactant side, we have 1 nitrogen, 3 hydrogen. On our product side, we have 2 nitrogen and 2 hydrogen. So you have a 3 and a 2. So you're going to have to find a least common factor, I think is the term I'm trying to use here. 3 and 2 only have 6 in common. So in order to get to 6, we're going to have to put a 2 in front of the ammonia, which is going to give us 2 nitrogen and 6 hydrogen. And in order to get 6 hydrogen over here, we're going to have to put a 3. 3 times 2 is 6. So now both sides are equal, and you can double count. 2 times 1 is 2 nitrogen, 2 nitrogen, 2 times 3 is 6 hydrogen, 3 times 2 is 6 hydrogen. So now this reaction is balanced.